Yes, could you able to see the screen?
Yes, sir.
Yes, sir.
First point, let me discuss chain theory. Okay, about which let's open up the point. Oh, just do it. Hold on. System battery is low, charging is a need. Two structures I am showing now. Yes, students, could you able to understand this? Could you able to read it?
Yes, sir.
Yes, sir.
Good. See, at that time, people were, okay, it is not showing annotation that time. I can't show here. Okay, people were knowing valency. Means if cobalt is a metal and charge on that metal is +3, then if chlorides are there, then such how many chlorides will be there? 3 chlorides will be there. Why? For to balance the charge. That is what? The +3. But when ammonia like molecules were there, then how to describe that charge balancing? That was a challenge in front of the people. I repeat, people were knowing valencies. People were knowing charges. And charge compensation, charge balancing occurs in a compound that they were well knowing. They were knowing COCl3, about which there was no problem. But when they have to describe, now we know it is a complex, but at that time they were not knowing. Suppose NH3,5Cl, such complex is there. Or if CONH3,4Cl2, such complex remains, then how to describe that? Actually here Cl followed by outside there will be Cl2. Here only one Cl. Such compounds were there. So they were knowing Cl minus. They were understanding role of Cl minus. They were understanding role of negative ion. But what's the role of this neutral ammonia? Ammonia carries no charge, no? Ammonia I am saying. Ammonia means NH3. NH3 has no charge. But why NH3 is there? That people have to describe. So to describe that, this chain theory came. It is a completely wrong. But how people went on thinking about developments of the compound, for that, that's a chain theory I introduced. Up to here, is it clear?
Yes, sir.
Yes, sir.
Yeah.
Yes, sir.
See this. First, CONH3 6Cl3. 6 ammonia are there, 6 ammonia, and 3 chlorides are there. So what people thought, this NH3 links with Cl, means NH3 Cl minus, or this NH3 and then Cl, or NH3Cl, means 6 whoever are ammonia are there. So one were 1 ammonia, other were 2nd ammonia, and remaining 4 ammonia will be with what? The 1 chloride. So that chloride remains with the ammonia, and that what the points through ammonia. So ammonia remains in between joiner or chain formation molecule. It was their expectation. Yes, could you able to understand what I'm saying?
Yes, sir.
Okay. Now I make the concept more clear. Here CONH3, actually they have shown 3. It should be CONH3. 5 should be there here actually. I could not represent that. So how they consider that one Cl is there, no? The 2 chlorides they could able to find. So those 2 chlorides they linked to ammonia, and 1 chloride which is inside directly they have linked. It is a good development they did, good understanding or good prediction they did. It's just a prediction. Why for were they predicting? They're predicting because of the number of ions. Here number of ions are 3, and therefore this structure they were considering. Means what they were considering, these chlorides are there, no? They are ionizable. Which one? This one, who are attached to ammonia. Means it's a chain molecule. This chloride is ionizable, but 3rd chloride is not. So 2 chlorides are ionized and remaining complex ion is there. So total 3 ions will be there. Depending upon the number of ions, people were concluding its structure. Suppose if I decrease 1 more ammonia, means 4 ammonia, then 2 chlorides are there, which are linked directly to the cobalt, which are not ionizable. But here This chloride is ionizable. So this chloride and remaining complex ion, this remaining complex ion. So only two ions will be there. It was their expectation. Problem came here. When they were considering CONH3Cl3, means all chlorides are inside. At that time they said this ammonia means three ammonia are there and it is linked to what the chloride and it is ionizable. Means from their point of view, it is ionizable and it will give two ions. One is complex ion and other is the chloride ion. So it is by which formula? It is by chain formula. Means whatever the right side numbers are there, number of ions, it is as per the chain theory. But left side is what the Werner's theory. And you will find Werner is more correct. Are you understanding or I need to give further explanation? Yes, please reply.
Repeat, sir.
Okay, good. Now pay attention. I want your help now. With your help, with your replies, let we make our concept clear. COCl3, such ionic compound I want to consider. This compound will ionize, will dissociate in water. In which manner? Which ions will be there? For example, NaCl, you put in water, Na plus Cl minus, CaCl2, Ca plus 2, 2Cl minus. Likewise, cobalt chloride, COCl3 will give which ions?
CO plus.
CO plus and
Cl minus.
CCl minus.
Cl minus. And important is how many Cl minus? Yes, reply please.
1 minus.
No, Cl minus, but how many chlorides are here? Here number is there, no?
3.
3 Cl minus. So if you are considering 3 Cl minus and you are very confident that chloride carries -1 charge, says -1 charged ions, how many are there? 3. Means total minus charge is -3. Then what should be the charge on cobalt?
Plus 3.
Right, plus 3. It is a mode of ionization. People were knowing actually this, but only for coordination compound, they changed their concept. So total number of ions, how many are there? Total number of ions which are ionized here, no? How many ions you are finding?
4.
Right, cobalt plus 3 is a 1 ion. And this 3 Cl minus, such 3 ions are there. Total number of ions are 4. People were so involved to discuss the coordination compounds, they say in the chain theory, that they have not paid towards the ionic compound, their description. So only for understanding of number of ions, I had given you this example. But our main concern or importance is coordination compounds. So one coordination compound, as we know so far, as per the Werner's theory, so for well-reputed theory, it also has limitation, but formulation and the basic understanding, Werner changed the scenario. If I consider a complex where cobalt plus 3 is a central metal ion, I hope till now you know the term central metal ion, ligands, number of ligands, or coordination number, or charge on the metal ion, or charge on the complex. All those basic terms, videos are prepared, and I think you might have went through those all videos. And if I consider such complex, NH3 6 Cl3, such complex people were knowing. What is explanation by chain theory for this complex? Chain theory says cobalt plus 3 is there at center, and this cobalt plus 3 is binded to one NH3 and one Cl minus. Cobalt plus 3 is binded to further one NH3 and Cl minus. And one more chloride is there, it is binded to NH3. But what they were considering NH3, how many NH3 are there? Total 6 NH3 are there. So to explain those 6 NH3, one already considered, second already considered. So one NH3 is second NH3, third NH3, fourth NH3, and then they were considering Cl. So what is their expectation from this complex or from this structure? Whichever this NH3Cl bond is there, it is ionizable and will give NH3 plus Cl minus. Charge and all they are not considered in detail. It will give one Cl minus or. It will bind. This NH3 is linked to what? Cobalt. That complex is there. So one Cl minus it will get. It will give other Cl minus and the third Cl minus. Such 3 Cl minus will come out from this complex. How many Cl minus? 3 Cl minus ions will come out. And remaining structure is there, no? I represent that remaining structure by other color. Remaining structure means it is a cobalt, this ammonia, this ammonia and this ammonia, this structure. This structure is separate ion and that carries +3 charge. Only one ion and 3 Cl. So I represent it is a complex ion. One complex ion plus 3 Cl minus. Now answer for my question, how many ions are there in this complex? One complex ion and 3 Cl minus ion. How many ions are there?
4.
Right,
Four.
four. Werner also said the same thing. He said there are 4 ions. One complex ion, but charge on that we said +3 and this 3 Cl minus as usual. So at first instance, they thought it is correct. Chain theory, no? It is correct. Let us ask the chain theory to describe further molecule. Say CONH3 5Cl Cl2. Then what chain theory did? Chain theory said cobalt, metal ion is there, cobalt +3, but they could able to find only 2 Cl minus outside, no? Out of 3. So they said that one Cl is there, no, which is not ionized. It is directly linked to chloride. Sorry, cobalt. One Cl, this Cl, which is not ionized, is directly linked to cobalt. And these 2 Cl minus, which are ionizable, they are not directly linked. Through chain, they are linked. Ammonia, one molecule also is sufficient to have the chain. And this Cl. Other, see total how many ammonia I am with here in this structure, in this molecule. Help me. How many ammonia are there?
5.
5.
Five.
Out of that, how many already I had considered here?
1.
1. How many are left? Yes. How many are left now?
4.
4.
4. So these 4 ammonia and 1 Cl, they are saying by chain theory, it is ionizable. It is ionizable. So how many Cl minus I found here? 2 Cl minus I found, which are ionizable. And remaining whatever the structure is there, I represent it by other color. This remaining structure. Here one ammonia, cobalt, this chloride will not come there. Side, yes. This ammonia also, yes. This is our complex ion plus 2 Cl minus. Now answer for my question. How many ions are there? Total?
3.
Yes. Total ions are here 4 were there, here 3. As per Werner's theory, this complex ion which carries +2 charge and this chloride 2 Cl minus charge. So total 3 ions are there. Means here what is happening? Where that's the chain theory is giving same number of ions as like Werner's theory. Are you understanding what I am talking?
Yes, sir.
Yes,
Yes, sir.
Very good, very good, very good, very good. Now let us ask the question to chain theory. New question, new molecule, new complex. Say CONH3 Yes. How many chlorides they are finding outside?
No.
No chlorides.
0.
0. So what they could do as per their understanding, they have considered cobalt at the center. So chlorides are not ionizing. So chlorides are there directly linked to Cl. Directly linked to Cl. Directly linked to Cl. It should be their explanation as per the chloride ion ionization. But problem came to show or represent ammonia molecules. Where can they be represented? There is no alternative. Chain 3 already said chain of ammonia followed by what? The chloride. So they sacrificed the one in their explanation, one chloride, and they said there are 3 ammonia. What are the ammonia are there? No? Those will be there. There are 3 ammonia, NH3, then NH3, then NH3, and then Cl. This structure they have given for this molecule. At least somewhat clarity will be there. As per this structure, I want help from you now. As per this structure, how many ions should be there? Okay, answer. Is this chloride ionizable? Is it ionizable as per chain theory? As per our previous discussion?
No.
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 Means this chloride is not coming out. Is this chloride ionizable?
No.
No.
Means that chloride also will not come out. Is this chloride ionizable?
Yes.
Yes.
Yes, absolutely. So 1 Cl minus you will find plus remaining whichever the entities are there here. This chloride will be there, this cobalt will be there, this chloride will be there, and this ammonia will be there. This it includes complex ion. Answer for my question. In this molecule, as per chain theory, how many ions are there?
2.
Great, great. Two ions. As per Werner's theory, how many ions should be there? Here cobalt carries plus 3 charge. Three chlorides will carry minus 3 charge, and all are inside the square bracket, not ionizable. So complex will be neutral molecule. Ion will not be there. So number of ions as per Werner's theory for this complex, 0. Here disparity, here dispute, you will understand. Werner's theory says one and chain theory says other. And actually here is a limitation, demerit or mistake. Right from basic mistake is there in the chain theory. But people, see, science develops in that way only. Silly attempts, they remain. Now we know silly, but at that time they were not with any option, no? So whatever the option at least partly could explain, they do accept that. Accordingly, they have accepted by the end of the 19th century this chain theory. But later on in 20th century, beginning of 20th century, complete world of coordination chemistry changed because of genuine scientist Alfred Werner. Yes. So chain theory's idea was there is a chain of ammonia molecule followed by chloride which is ionizable. If that chain is not involved, then that chloride is not ionizable because they could able to understand few chlorides only are coming out. So whoever coming out, whoever dissociating, whoever are ionizing, to that they applied in the chain form. Ammonia chain means cobalt ammonia complex only at that beginning studied. Therefore, I had considered this example. Saurabh, is the answer clear to you?
Yes, sir.
Other students, the question asked by Saurabh and answer I provided now. Is it clear?
Yes, sir.
Yes, sir.
Yes. Yes, good, good. Now, next question was about assignment number 4, no? Am I right?
Yes.
4. And I think it is regarding feedback. Means I had taken the feedback from it. What is our conclusion? Whatever the lectures, means in lecture what happens? Discussion. Maybe that's a general discussion. Maybe policy decision. Policy means our strategy decision. Maybe chemistry. It is a lecture. And that lecture, all other students are attending who are live or online. For others, what? Those who are not online, they also should know what discussion took place. Therefore, I post that video, post that lecture on the YouTube. So you go through those lecture. But as an assignment, I ask you to prepare notes. Notes is what? It is a summary of that lecture. So let it be the general discussion lecture or let it be the chemistry discussion lecture. Means in general strategy, policy or other science subjects also may be there. So if assignment is given, why assignment is given? So let everybody should go through that lecture. Let you know the feedback. You only have given the feedback, no? So feedback. So who had given what feedback as such in detail to write on? I'm not expecting. At least you to go through that. And these many students are given. These many students were present. These students have given the feedback, and all students have said that our system should, in continuation, our system of assignment providing is good. Let it come on the record. It's what the notes. So notes means summary of the lecture we have to write. Here what excuse I can say, here number of words or number of sentences is left to you. I'm not, but if subject remains, then you have to with example, you have to explain. Chemistry remains, then some detailed study, detailed notes you have to. And assignment is the one way by which I can understand whether student has went through that lecture or not. Therefore, I ask you to prepare the notes of that. Notes means summary of the lecture. Prathamesh, is it clear?
Yes, sir.
Other students, question asked by Prathamesh and answer I provided. Is it clear? Because this question was asked by Saurabh also one time, but I had answered him when he asked me in the WhatsApp, through WhatsApp. Then when dialogues, I understood whatever his dialogues are there, I understood. Immediately I replied. Yeah. Is the reply clear for all?
Yes, sir.
Yes, sir.
Yes, sir.
Yeah, good. Who has asked? The same question was asked before. Okay, so it is clear now. Yeah. Any other question? One more question was there, no? So, chain 3 coordination compound. Okay, I discussed that. But feedback, okay. Saurabh has given the reply, feedback as assignment number 4. Okay, Sahil and all you're saying here, no? I was not knowing that what you did given the message because I was on the presentation screen. So always remember, when I remain on the presentation screen, I could not read the charts or your messages. So students, shall I go to the next point?
Yes, sir.
Yes, sir.
Yes, sir.
Sir. Yes, next point is oxidation states. I know that we have decided to follow this time a new strategy of follow sessions. So transition series number 1 and transition series number 2, their elements, their electronic configuration, you might have studied. Have you completed that?
Yes, sir.
Yes, sir.
Yes, sir.
Good. So those who have not completed, one more chance I am giving. Today you complete, tomorrow I am going to ask. Let me complete now the concept of oxidation states about the first transition series especially. What is meant by oxidation state? That I discussed last time, but still if doubts are there or concept is not clear, you can ask me. It's a basic aspect. The charge beared by the element in that compound. It is found that these transition series elements, they show variable oxidation states. Variable means not a particular fix. For example, Na plus, only one charge, only one oxidation state. Calcium plus 2, only one oxidation state, no other oxidation states. So fixed charges are there on few compounds or few elements or ions. But transition series element, it is found that they show wide range of oxidation state. If I consider manganese as an example, it shows the oxidation state from Mn plus 2 to Mn plus 7, such plus 2 to plus 7, wide range of the variation is there. Therefore, we conclude oxidation states are variable. So let me know what are the variable oxidation state. For that, two things you have to remember. The first one, minimum oxidation state, and second one, maximum oxidation state. Now listen carefully. What is the formula of minimum oxidation state? Minimum oxidation state is equal to number of electrons in 4s. I am talking about the first transition series elements. And maximum oxidation state is equal to this number plus number of unpaired electrons in other orbital. That's a d orbital. So if we know atomic number and if we know the electronic configuration, then we can understand this oxidation state. For that, you need to remember these two formulae. Now, minimum oxidation is equal to number of 4s electrons, and maximum oxidation is equal to that number is there plus number of not only electrons, unpaired electrons. In which orbital? 3d orbital. Now let us understand our elements. The element with atomic number 21. Yes, help me.
Scandium.
DM.
Scandium. Yes. Its electronic configuration means orgon, that completion is there, followed by
3D14S2.
3D14S2.
3D14S2. Now, what are the concept I told to you? Let us apply. Its minimum oxidation state, we will calculate, and other maximum oxidation state, that also we will calculate as per our formula. Minimum oxidation is equal to number of electrons in, yes, help me, number of electrons in
4s orbit.
Yes. So how many electrons are there?
2.
So minimum oxidation state for scandium is plus 2. Metal, no? So positive charge. Maximum oxidation state is equal to electrons in 4s plus number of unpaired electrons in 3d. How many unpaired electrons are there?
1.
1. So total
Plus 3.
plus 3. So scandium can show two oxidation state. Which are those? Plus 2 and plus 3. It is understanding of minimum and maximum oxidation state and application of that concept to one element, that's a scandium. Let me continue my discussion for next element. Say yes, next element.
Titanium.
Titanium. Its electronic configuration. Yes.
3D2 4s2.
3D2 4s2. So minimum oxidation state is equal to number of electrons in 4s orbital. How many are there?
2.
2.
So plus 2 is the minimum oxidation state. Maximum oxidation state is equal to number of electrons in 4s. That's a 2. Plus how many unpaired electrons are there in the d orbital here?
2.
2. So total
4.
Plus 4.
Right, means scandium can show +2, +3, and +4. These three oxidation state, three variable results for oxidation state. Is it clear? Are you following?
Yes, sir.
Yes, sir.
Let us apply this concept for one more molecule. That's next. Yes, tell me, not molecule, actually element. Yes, which is that?
Vanadium.
Vanadium.
Vanadium. Electronic configuration, outer.
3D3
3D3
4s2.
4s2.
3D3 4s2. Yes, minimum oxygen state.
2.
2
Yes, +2 because two electrons are there in 4s orbital. Maximum oxygen state.
plus 5.
Yes, 2 plus number of unpaired electrons in 3D, those are 3. So maximum oxygen state will be +5. So vanadium will show variation in charges +2, +3, +4, and +5. Are you understanding?
Yes, sir.
Yes, sir.
Yes. Now important element. Atomic number 24.
Chromium.
Chromium.
Chromium. Electronic configuration argon. Yes, help me now.
3D5
4s1.
4s1.
Very good, very good. All are brilliant. See, chromium is the exception where only one electron is there in the 4s orbital. So as per our logic, as per our rule, minimum oxidation state will be
1.
1.
+1. +1 because only one electron is here, no? Maximum oxygen is equal to 1 plus how many unpaired electrons are there?
5.
5.
So total +6. So scandium can show here actually 6 can show oxygen state from not +1, from +1, +2, +3, +4, +5, and +6. Maximum +6. Okay. So here one element you found where start is from +1. Next element is manganese. Its electronic configuration argon 3D. Yes, help me.
3D5 4s2.
3D5 4s2. So minimum oxygen state.
2.
Yes. What is the minimum oxygen state here?
5.
Minimum. Number of electrons in 4s orbital.
Plus
2.
2.
+2. And maximum is equal to
5.
how? Number of electrons in 4s
+7.
plus number of unpaired electrons in 3D. 3D, how many unpaired electrons are there? 5. Could you able to understand d orbital if I represent? Then 5 electrons. One window seat, second window seat, third window seat, fourth window seat, and fifth window seat. 5 unpaired electrons are there here. So total maximum oxidation state possible +2 plus 5 is equal to +7. So manganese will show variation from +2, +3, +4, +5, +6, and +7. Could you able to understand what I'm saying?
Yes, sir.
Now one more example you have to answer, but wisely answer. I want to consider element with atomic number 27. Yes, which is that element?
Cuprum.
Cobalt.
27.
Cobalt.
Cobalt.
Right, cobalt. Iron 26, cobalt 27, nickel 28, and then cuprum will be there 29. Okay. Now mistake is that don't worry at all, but you are tempted, it's a great thing. So 27 electrons, electronic configuration, argon. Then yes, help me. What will be the electronic configuration?
3D7 4s2.
Yes, 374s2. Good logic you applied now. So minimum oxidation state will be
2.
2 because 2 electrons are there in 4s orbital. Maximum oxygen state will be
7.
Plus 9.
7.
+9. Here, don't follow blindly. Think on that. 2. Okay, plus how many unpaired electrons are there in 3d7 configuration? Just d orbitals means 5d sublevel means 5 orbitals will be there. Substitute electrons at the beginning window sheets. Outer pairing will be there. I want unpaired electrons. Number of unpaired electrons. How many previously what was happening? Which electrons are there in d orbital? Those were unpaired. But now in this example, case is different. No, I'm not understanding where is the problem. Is my question clear?
Repeat, sir.
Repeat.
In 3d7, how many unpaired electrons are there in this 3d7 configuration? 3.
3.
3.
Yes. Those who could not answer immediately, for them, see. Generally, first electron, second electron, third electron, fourth, fifth. These are the 5 window sheets, 5 unpaired electrons. After d5, actually pairing starts. Sixth electron, seventh electron. Our question was how many unpaired electrons are there? So these are the unpaired electrons. And how many are there? 3. So what's total?
Plus 5.
plus 5. So cobalt will show the variation from plus 2 to plus 5. So in between plus 3 and plus 4 also will be there. Similarly, you can work for other transition series metal ions. Two formulae are there. One that's minimum oxygen state is equal to number of electrons in 4s orbital, and second, maximum oxygen state is equal to number of electrons in 4s orbital plus number of, listen, unpaired electrons in 3d orbital. And with that you can calculate the variable oxidation states. So these are the possible oxidation state by first transition series elements. But problem is each oxidation state is not equally stable. It is found that transition series element show in general tri-positive oxidation state. It's a general, I am saying. General means if you take scandium, then scandium plus 2 and scandium plus 3 both are possible, but scandium plus 3 is more stable. If you take, say, iron, Fe plus 2 and Fe plus 3, Fe plus 3 is more stable. If you take cobalt, Co plus 2, Co plus 3, Co plus 4, Co plus 5, all possible. But Co plus 3 is stable. Means in general, I'm saying it is always stable. In case of manganese, Mn plus 2 is stable. Mn plus 7 is stable. But Mn plus 3 is not as stable as Mn plus 2 or Mn plus 7. So again, it depends upon the electronic configuration. What I'm saying, stability. Stability of the oxidation state. At the beginning, I told you oxidation states only. Possible oxidation state. Now I am talking about which oxidation states are stable. In general, it is found tri-positive. In general, it is now. Tri-positive oxidation states are more stable, especially for first transition series elements or majoritically transition series elements. Now question arises, on what ground this stability depends? Then at the beginning, people were attempting it to explain by means of electronic configuration. Means if I take Fe plus 2 and Fe plus 3, these two ions, Fe plus 2, what's electronic configuration? Yes, iron atomic number?
26.
26.
26. So s orbital electron generally goes out. So how many electrons are there in the plus 2 oxygen state? Plus 2 means 4s electrons went out. Chromium and copper only are exceptions. When positive charge comes, electron from s orbital will go. And the extra electron necessary, then only from d it will go. So Fe plus 2 I am talking about. So electron from 4s will go out. So in Fe means only simply suppose if you consider iron, then in d orbital, how many electrons are there? Yes, 26 means what is last digit?
6.
6. So 6 electrons are there in d orbital in Fe plus 2. What about Fe plus 3? 2 electrons from 4s will go out. But plus 3, no? Charge plus 3 means 3 electrons you have to remove, not only 2. So third electron will go from d. So naturally, iron remains with 6 electrons in its d orbital. But one more electron extra went out, no? And because of that extra electron furnishment going out, that number will decrease. And what will be that number? D?
5.
5.
D5. Now, among these 6 and D5, who is stable? Who is more stable? D5 is more stable because d orbital accommodating ability 10 electrons. Out of that 5. So 5 is the exact half number. No? There's half filled orbitals are more stable. So compared to D6, where neither it is a completely half filled, not completely fulfilled. Therefore, compared to D6, D5 is stable. And because of that, for chromium, adjustment is done. And one electron is entering the d orbital because only one electron change is necessary, no? And that chromium becomes stable because of D5 configuration. Students, are you understanding what I'm saying?
Yes, sir.
Yes, sir.
Yeah. Similarly for copper, for that fulfilled orbital, D10, copper does change. In 4s, it keeps only one electron, and it's a general explanation. So on the basis of electronic configuration, we could explain the tri-positive oxidation state. Now, if we come to manganese, next example I am considering now. Yes, what's the atomic number of manganese?
25.
25. Let me consider Mn plus 2 and Mn plus 3. Answer for my question. Mn plus 2 has how many electrons?
5.
Right?
5.
Mn plus 3 has how many electrons?
4.
4. As per
6.
your... No, plus 3. No. One electron went out extra. Electron decrease. 5 were there, plus 3. No, you're removing electron. If you remove electron number will decrease. No, from 5, it will come to 4. Is it clear?
Yes, sir.
Yeah. So D5 and D4. Among these, who is stable?
D5.
Yes, D5 is stable. So Mn plus 2 should be stable. Means Mn plus 3 should not be. But Mn plus 3 is occurring. I'm not saying not occurring. Mn plus 2 is certainly stable. But reasons for stability are different. Then question arises, on what factor does this stability do depend? And that answer is in thermodynamics. It's a perfect answer. Electronic configuration, whatever explanations are there, vague explanation, general way. But at the beginning, people could able to explain, no, Fe plus 3, why it is stable. So they were influenced by the electronic configuration concept to describe the stability. But the main concept is thermodynamic concept. The thermodynamic concept says the stability of oxidation state depends on 3 factors. Listen carefully. Stability of oxidation state depends upon 3 factors. The first factor is sublimation energy. Because if we want to obtain the ion, in definition of ionization energy, it is the energy needed to remove the electron from isolated gaseous atom. Listen carefully. Gaseous atom, if we have to obtain, then we have to convert solid to gas. What is that process where conversion of solid to gas occurs? That process is
Sublimation.
right. That is what the sublimation process, sublimation energy. Now, second factor after sublimation, ionization is our second factor on which stability depends. Ionization energy means energy needed to remove electron. Energy needed. Listen, energy needed. For first factor, also energy needed. Second factor also energy needed. Now third factor, that is solvation energy or lattice energy. Lattice is when in a solid formation. If that compound is solid, then lattice energy. If that compound is in solution form, compound may be solid, but if it is solution form, then solvation energy will help us to answer. Solvation energy for that metal ion I am talking about. Because we are talking here oxidation states of those metal ions. Now when solvation occurs, lattice formation occurs, answer for my question, energy will come out or energy will be absorbed, energy will be needed?
Come out.
Right, that energy will come out. Out of these 3 factors, there is only one factor here where energy is coming out. And these 2 factors are there where energy is absorbed. I said in ionic compound last semester, it's a perfect business. Our molecules, atoms or ions are perfect businessmen. Always they remain in profit. And profit is in terms of energy loss. Energy loss means low energy for them. Low energy means they are stable. More energy within them, then they will be active, reactive. So as energy decreases within the system, that system will be the stable. But among these all 3 factors, only one way is there by which energy can be given out, and remaining 2 are there, energy is absorbed. So combination of all those decides the stability, and it's a matter of chance. It is found tripositive metal ions. The combination of all these 3 is in such a way that ions are more stable. Are you understanding what I'm saying, or it's a bouncing?
No, sir. Understood.
Yes, sir.
Okay, what about girls? Today girls are not answering. Are they there or not?
Not.
Oh, nobody is there. What? Strike? Okay, they might have thought the video lectures with which they can go. Okay, doesn't matter. If any such issue is there, if any problems are there, bring it to my notice. If somewhere I am wrong or anything happened, then also bring it to my notice. Have a clarity. I'm not biased here. Let anybody be there or may not be. It's your choice. But if you are not attending, then reason also I should know. No, therefore just I ask. Is it clear?
Yes, sir. Yes, sir.
Yes, students. Shall we stop now?
Okay, sir.
Yes, so students, I declare here today's session is over. I stop the recording. Quit now. Okay, Shilpa is there.